Hello, everyone. This is Sammy. The topic is understanding ideal gas behavior graphically. And the question is, which of the following five graphs does not represent ideal gas behavior? So let's go ahead and look at graph. We have pressure versus temperature, and the graph is a line going straight up. Okay, so we need to look at the ideal gas equation, which is PV equals nRT. So P is pressure, V is volume, N is the number of moles, R is the universal gas constant, and T is temperature. So here, as we increase the temperature, we are increasing the pressure. So if you look at the ideal gas equation, if we increase the temperature, we are going to increase the pressure. So temperature is directly proportional to the pressure. So graph A is actually correct. Okay, that's correct. Let's go to graph B, and let's go ahead and apply the same equation as before. Okay, so we have PV equals nRT. So this graph is volume versus temperature. It's a line going up. Okay, so as we increase the temperature, the volume is increasing. Let's look at the ideal gas equation. So if we increase the temperature, we're going to increase the volume. Yes, that is true. So graph of B is correct. Let's go to graph C. So it's pressure versus volume. It's actually a line curving downward. So as we increase the volume, the pressure is decreasing. So if we look at the ideal gas equation, PV equals nRT. If we increase the volume, the pressure is going to decrease. They're inversely proportional. If one goes up, the other one must go down. So this graph of C is correct. Let's look at graph D. So it's P versus 1 over V. So as we increase 1 over V, the pressure increases. So the ideal gas equation is PV equals nRT. To get 1 over V, we actually have to divide both sides by V. So the V's on the left side will cancel out. We'll get P is equal to nRT times 1 over V. So as we increase, we have to treat 1 over V as an entity by itself. So if we increase 1 over V, then the pressure is going to increase as well. Yes, that is true. They are directly proportional. So D is correct. Let's look at E. So we have the entity of P times V. You have to treat that as one variable, PV versus temperature. Okay, so as we increase the temperature, the P entity PV is staying constant. Is that correct? Let's look at the ideal gas equation. PV equals nRT. So if we increase the temperature and we treat PV as an entity, that should be increasing as well. So this graph right here is actually incorrect. So E would be the answer. Now, what this graph would actually look like is, let me draw that better. What that graph would look like is you have PV versus T. So as we increase the T, PV is increasing. So it actually looks something like this. And that would be the answer.